Hello, and welcome to Two Dancing Clams. This is a Blender 3.3 tutorial for animation along a curve inside a translucent crystal. The techniques presented here show how to smooth out the animation of an object along a line to any precision, and how to create a natural-looking crystal in a scene with no other objects. Because this project is designed to be animated, the steps required to produce the final animated sequence will also be covered. Glass in Blender is lovely but tricky. A purely transparent object is only made visible from the reflections of other objects in the same environment. I wanted to have a moving sprite as a light source to produce interesting reflections in the crystal without having to depend on external geometry. This is also good for me because I dislike putting objects into a tutorial video that are not created as part of the tutorial. This being said, placing this crystal into a scene with the facets picking up external reflections and the light spreading to nearby objects is amazing. I was also motivated to put this together after watching a few videos on similar topics. The results I was seeing were somewhat jerky, and slowing them down just made the large steps more obvious. I needed a way to smooth out movement along the curve into arbitrarily small steps without changing the shape of the curve. I also needed to have a predictable number of frames for animation purposes. This project is available on Gumroad. Check the link in the description below. First off, enable Node Wrangler. Edit, Preferences, Add-ons, Node Wrangler. And there we have it. Now I'm going to create some geometry nodes. Give it a name. I will not need the starting cube. What we're going to do is take a collection of random points, and we're going to use that as a basis to form the path that the sprite is going to travel along, and we're going to use it as the bounding box, or actually the convex hull that our crystal is going to be composed of. So we'll create some points. I want to put this under the control of the user. Drag this out to group input, which will create a new value for us here. I'll call this scatter points. And it will create a value, and the same value will be displayed over here. And let's change this to 30. So this will control the number of points we get, and also we will expose that to the user interface. So in the future, whoever is running this node group can change their mind. We want these to be random. Don't really care how big they are, but other parts of the algorithm expect the box to be centered on the origin. So that's the only thing I really need. So let's make this -1 to +1 centered on the origin. Instead of a loose collection of points, I need a continuous line that threads its way through these points. The easiest way to do that is to start with a circle, believe it or not. And the circle will have exactly as many points as this group does. And essentially, we're going to take all of the points of the circle and move them to be the consecutive points along this scatter plot, generating a curve in space. So we have our circle. We're going to do a set position. We need to get this geometry is its own thing, and this circle is its own thing. They're separate. So we need to copy attributes from one of these pieces of geometry to the other. And the way that is done is with transfer attributes. The source will be these points. We're going to be transferring a position, so that is a vector. It's actually a triplet, but they call it a vector. We're going to do it by index. And the attribute we're going to transfer is position. And there we go. The point that is at index 0 in this geometry is copied over to the circle point at index 0 along the circle. Index 1 is copied to index 1, and so forth. We could put an index value in here, but there's no need. The default is fine. Now we want to make this look more like a proper curve. So give ourselves some room. We're going to make this a Bezier, because that Bezier, by definition, can draw a smooth curve through all the points specified, but it's only smooth if you tell it to be, and we'll tell it to be with a set handle type. And there you have it. Now we have a nicely swoopy curve. And I'm not going to want to see these anymore. We're going to replace it with something better. Okay, so there's the basis of our curve. It is a curve that is randomly tracing its way through 30 points. Now, first time through I stopped here, but it turns out that these points are set a little bit too far apart, and the thing that travels along the points is kind of herky-jerky, especially if you slow it down. I want it to be smooth. More than that, I want to be able to control the smoothness of it. So what we're going to do is take this curve and we're going to break it down into smaller pieces. But we want to preserve the overall shape of this curve. I don't want to just make this curve 10 times more complicated. I want to get 10 times as many divisions along the existing curve. The way we do that is with a subdivide curve. And I want this to be under control of the interface as well. So if I drag this off to group input, I get a new value. They're going to call it cuts. I want to call it points between. So I'll call this 10. So that means we have 30 control points and we have 10 divisions between them, which means if we want to do one complete lap around the circle, it's going to be this number times this number, 30 times 10, which is going to be 300. So later when we animate this, I'm going to draw 300 frames, and that will bring us through one entire loop. If you change either one of these numbers and you want to animate it afterwards, you have to go back and change the frame count. I've looked for a way to automate this. I thought I might be able to do it with drivers, but I don't see how. So if anybody knows how to tie these values to a frame count, let me know in the comments below. You'll be my hero of the day. It is really handy now, and even in the finished project, to be able to see all the points the line is going through. So let's provide a way to see that right now. Do an instance on points. Do a sphere to mark them. Make them small. So now we can see each of those points. That will come in handy, promise. Actually, it's kind of handy to see it right now. So this gives you the idea of where we're going. So we're going to take a series of contiguous points and put an object along them, and then make that object right through this curve. So as we increase the points between, we can make the moving object slow down and move more smoothly. If we decrease it, we can decrease it all the way to 0 and get back to the original. It all depends on what you want to do. For now, I'm going to leave it at 10. I want this to be usable at all times, but I don't want it to be visible at all times. So let's put that under the control of the interface as well. Create a switch statement. Drag this out to group input to create a new value. Call this show points. If it's true or not 0, I want to be able to see the points. If it's 0, I don't. So now as we're debugging and trying to get things to work, also trying to shape the curve to make sure all points of it are inside the crystal, we can turn this on. But when we want to render or animate, assuming you don't want to see this when you render or animate, just turn it back off. I said before that the number of frames is going to be scatter point times points in between. The way it's currently set up, that's not quite true, because if points between is 0, then 0 times 30 is going to be 0, that's 0 frames. That's not what we want. Actually, the floor on points between is 1. So if we subtract 1 from points between, now we can multiply these together and get the actual total number of frames. Love it. Now let's create the thing that's going to travel along. It's going to be based on a line. It's going to cover a few of these. I'll let the user pick how many of these it's going to cover. So actually, over here, seeing the points is good enough. We don't really need to see the line. So let's create a line. filter sample it to control the number of points on it, and put this under control of the user interface. Drag this out into space, go to group input, and we'll call this sprite length. This is the number of continuous points along the curve that the sprite will occupy. Well, let's go down to like 8 for now. Let's see how that looks. We'll want to place this on the curve with a set position. And let's go ahead and see what we're doing. Now clearly this is going to be at the origin because we haven't actually set the position yet. Where the position is going to come from, it's going to come from this other curve. And it's exactly the same trick we did before. We're going to use transfer attribute to copy by index a position from here to a position to here. The difference this time is the index is going to move. It's not always going to be 0 to 0, 1 to 1, 2 to 2, etc. It's going to be some place along the curve starting at 0, and that's going to control the movement of this little sprite along the curve. Transfer attribute. We want a vector. We are going to do it by index, even though we're going to pick an index this time. And there we go. That's the starting position for our little sprite friend. Now it's time to give the sprite a little shape. I want it to be a tapering cone that goes along the curve. First, we'll give it the same treatment as the other curve by changing it to Bezier and making the points smooth. And we'll give it a radius that we used to make it taper. This radius will be used to shape the profile. So to give it a profile, we'll do a curve to mesh. And that profile will be a circle. Now we'll give it, yeah, see, okay, it's working. But again, I want it to be tapered, not just a tube. So the taper will be provided by dividing the index by the number of segments. So at the beginning, it'll be 0 width, and then we'll go up to some final width. Divide the index along the line by the sprite length. That'll give us a 0 to 1 value. And of course, that's ridiculously big at the end. So we'll drag out and create a new group input and call this one sprite size. And turn it down to something reasonable. We can also use this to control the size of the glowing ball we're about to stick on the end, so that way they'll scale together. Let's do that right now. We need a sphere, so let's create one of those. And make it smooth. The size will come from that scaling factor we just created. I want the head to be a little bit bigger than the tail leading up to it, so let's do that. And how about like a scaling factor of 1.5 to start? We'll let it set position. Okay, now it's at the origin because we haven't moved it yet. Where do we want to move it to? We want to move it to the index at the end of our little tail. So I'll expand this group input. I will grab the sprite length, subtract 1 to bring it back to just the end of the sprite rather than one beyond. Now we need to get the position from this curve, from where the end of this thing is, to our new sphere. And again, this is one geometry, this is another. What do we use to move information from one geometry to another? A transfer attribute. Amazing. 10 out of 10. Again, we need the triplet. We're going to do this by index, and we want to move the position. The source geometry will be this curve we just created. And the index will be what we've just calculated. Wrong geometry. There we go. Now we have a cute little fella. Let's make the head smooth. The plan is to have this be a light source, and this catch the light source, and the crystal surrounding it catch the light. One important reason to allow the user to get control of the sprite is the bigger this area here is, the more light will fill the scene. So if you want dimmer reflections inside the crystal, more point-like reflections, then this could be scaled down. If you want more light, then you can scale it up. About 0.1 is a good place to start with. Now I want to make our sprite travel. We'll do that by changing its starting index along the big curve. And that will be here. When we change this index, we'll cause the starting location of this little sprite thing to move. Like so. So we could just whee. Lovely. But in practice, I don't want to do it this way. I want to control this in two different ways. First of all, I want to give control on the interface so we can play. Create a new group input. Call it frame start. Also want to be able to control it with the animation, with the frame count. So we use the scene timing node and grab the frame. So now, if we turn on animation, we get something very much like the final effect we want. Let's change this to a integer. And we can also play with it like this. But you'll see when it gets to the end, it stops. Don't want that. We want it to keep going. So let's add a modulo function. So when the index hits the end, it just wraps around back to 0. And actually, the total number of points is, as we said before, these two multiplied together. So now, okay, let's do shift left N to get the animation back to the start frame. And let's make sure this works. So as we get up to 300, so 296, 7, 8, 9, it's wrapping. That's probably going to work better. Okay, next thing we need to do is to create the crystal that this thing is going to sit within. This is really easily accomplished with a convex hull. So I see something here that I want to fix right away. The points sometimes go outside of the shape. This is because the points are following curved paths and the shape are following linear paths. The easiest way to solve this is just to provide a way to scale up the convex hull. It looks prettier when the sprite is contained within the gem, so the reflections are always internal. When the sprite goes outside, it looks very dark for a few frames. If that's the effect you want, then this is the control. You can make your points always inside or not as you choose. I just prefer them inside. We can do this with a set position. Scale the position of each vertex by, and I'm going to create a new group input. And I'll call this crystal scale. And now, whenever we get a new set of points, we can scale the crystal as we feel like. One more thing is I want to add a subdivision surface. I want to add a few more facets, but not too many. I don't want to get too busy, but I want it to be a little bit more complex than this. And I think that's a pretty enough look. However, in experimenting with this, one of the things I wanted to do, I like to play with this edge crease to approximate the difference between like a level 1 and a level 2. Yeah, I think that looks good. I think it's just the right amount of facets. Time to do some materials. Let's give ourselves 2 slots. I want to call one glow. Call one glow and one crystal. That will be our crystal. and the glow will come only from the little sphere. I want the tail to pick up the light from the sphere but not emit light. That's a choice you could make. I like it better this way though. The other thing I want to do before moving on is I want to be able to set the color as well, the color of the crystal. And I want that to be in this interface. So let's take care of that right now. I'm going to create a new attribute, call it crystal color, store attribute, and create a new group input, and call this one crystal color. There's a few different ways to accomplish this. All involve getting an attribute over here. I do like a store named attribute being put in geometry. It's a little less fiddly. I don't know. What this allows us to do is this value will carry all the way through into the shader editor, and we can pull it back out as an attribute. Now let's work on those materials. Bring up the shader editor. And this will be for the crystal. So this, we want to pull out this color we just created. We'll get an attribute node. We'll pull the color from it. And this is the crystal color. Turn on material preview. Nice! Now the crystal is going to be mostly transparent. To accomplish transparency, we set the transmission up to 1. And while I'm thinking about it, let's go up to the render properties, change this to cycles, and change it to GPU. If you have a GPU that's capable, if not, go ahead and let that be CPU rendered. Now we get our glass. An interesting thing about this is glass only shows as it reflects other things in the environment. We're not going to have anything else in this scene to reflect, except for the little sprite thing, but it's negligible. So I could add a bunch of things to the scene that will cause my glass thing to show, or I can give it just a touch of roughness so that the light has something to pick up on, but the overall effect is still transparency. So crank this down. If we crank it down all the way, our thing just disappears. So how about 0.14 for the roughness is good. This won't be terribly visible until we add some light, so let's do that now. Now for the glow, let's give it an emission strength of about 2000 and a color of white. Now, it's getting close. There's two ways you can handle this. One, you can make the gem completely white and then use a colored light, or you can make the gem a color and use a white light. And actually you can use both, but usually one will dominate, and it's just, I haven't seen a point in giving both of them color. So for the purposes of this thing, the gem is going to have a color, the light is going to be white. Let's go back to our geometry nodes. Okay, that is really nice. So we can turn on animation. Oh, that is so sweet. Let's go ahead and turn off the points for now. So you can see as we scale up the sprite, it gets a lot brighter. And if we scale it down, the light becomes more point-like, picks up the facets. It's really up to you. You can also play with the emission strength, balance those two out. And also if you make the crystal bigger, it will be proportionally dimmer. These are all things I play with. Let's do a quick render to see how we're doing here. I'm going to do a Control-Alt-0 on the current camera view, Control, and that will place our camera exactly where we're looking now, and F12 to render. This tells me two things. One, I really like where we are. This is almost exactly the effect I want. It also tells me that 4K samples is way too much. We can get by with 256. And that will dramatically, when we go to render all the frames for animation, that will dramatically shorten the amount of time it takes. One thing I want to do before we leave this is expose the seed. And we'll just leave the name at seed. I also do not want a gray background. I want white. I want a black background. I think it looks cooler just floating in space. Go to World Properties and change that to black. So now we can change the seed. Get, whatever shape you want. And again, if we, oh, there's the sprite. If we turn on the ship points, we can see when the curve is going outside of the crystal and make that not happen. This is easiest to do in Material Preview. You can do it here too. It's just a little harder to tell what's going on because you can see the points through the crystal. Another quick render. My card isn't really that fast. I sped up the video. I absolutely love this. Let's do the animation. To get the animation rolling, we have to do a few things. First of all, if for some reason this is not already in cycles, make sure it is. Get the max samples where you want them. Actually, you can go down to 128. That is where the quality starts to suffer a little bit. Maybe you'd care, maybe you don't. I think 256 is a nice limit. Go down to the output properties. Now, we said before that we have 30 control points and 10 divisions between them for a total of 300 frames. So let's do 300. If you wanted to do a smaller animation to start with, then you could turn down those numbers, multiply them together, and come back and put that value in here. We will need to give it an output directory. I created a directory earlier called render inside the temp, so I'll use that one to keep these separate. PNG is the default, and I like that. Basically, this will, instead of creating one movie, it will create 300 PNGs. Later, we'll come back and stitch those together into a movie. And that's safer, because that way if your computer has a problem, your cat steps on the power key, you get to save all the PNGs that were rendered up to that point, and you can come back and set the frame range to whatever you need to do to complete your render. But now we're ready to go. To start the animation rendering, go up to Render, Render Animation. And it goes. Now, as this is going, you want to come over to your render folder and make sure that the PNGs are actually being generated. You wouldn't want to go away for a few hours and come back and see that nothing's being done. But as you can see here, it's working. So I'm just going to let it roll. At some point in the future, we'll have finished the 300th image. Now let's stick them together into a video. In Blender, you do that with going to the video sequencer. We want to start the sequence back at 0, so shift left arrow. If you don't do that, then you'll add the pictures at the current playhead location, which is probably not what you want. Now we want to add all the PNGs we just created. Add image sequence. And just A to select them all. And then come back to the object output properties. Switch this from PNG to FFmpeg video. There are a lot of things to play with here. I really don't think any of it's necessary. I think this produces a very lovely result. So let's give it a whirl. Render, animation. This produces an MKV video file in the same folder that the PNG files went to. And now, view animation. That is amazing. I love this so much. I think it's one of the favorite projects I ever did. My actual vision for this is to use this as a light source inside temples and things like that. Put it on the end of a sconce or at the top of a column or something. I think it's going to look magnificent. There's a project file for this up on Gumroad. In addition to the freeform crystal that this one creates, I added a separate generator that takes in geometry from the user and does a similar trick to it. I hope you enjoyed this video. Thank you for watching.